Alright, what are ways to express knowledge of various equations? We're going to be dealing with part 2, what I call the ugly. Um, in this case, my goal is that you're going to be able to solve equations with variables on both sides and determine whether an equation has one solution, no solution, or infinitely many solutions. Alright, as we look at this one, now when you see my foldable, it is already filled out from before, but let's look at it. You have 5x plus 2 equals 8x plus 14. And let me do this so you can copy the problem down as we talk through it. 5x plus 2 equals 2x. I'm sorry, it wasn't 8x, it was 2x plus 14. I'm glad I went back. Alright, let's go back over here and let's kind of talk our way through this. I have 5x plus 2 equals 2x plus 14. There's really no big difference in what we've been doing. The only thing is you have a variable on both sides. You're always going to hear me say get the variable together first. So in this case, I'm going to try to keep it positive, and I can. I have a 2x there, so I want to subtract 2x from this side. And if I subtract 2x from this side, I have to do it on this side. When I do that, 5x minus 2x is going to be 3x. I brought down my 2. Now again, I look at the sign in front of it, which in this case is a positive. So I just brought down plus 2 equals, well, 2x minus 2x, it's gone. The only thing left there is a positive 14. I have a plus 14. So I just brought that down here. So it's going to be 3x plus 2 equals 14. From here, what I want to do is just like a regular multi-step equation. I want to get x by itself. Well, I have a 2 over here. It's positive. So I have to take the negative. Subtract 2 from this side, subtract 2 from this side. And I do that, it's going to give me 3x equals 12. From there, I have 3x equals 12. Again, to get x by itself, and I divide, because if I look at, I'm not trying to move the whole 3x, I just need to move the 3. They are multiplying, so I do the inverse and divide. 3 divided by 3, which is x. 12 divided by 3 is 4. So you should have x equals 4. And I'll move this over just a little bit so you can actually see it. And copy down anything you need to copy down there. And then we're going to practice some of these. Alright. As we go back. Again, now, what I want you to do is use what we just did on the foldable and apply it to this. I want you to work this problem out first. And then we'll go over it. But pause the video. Again, I expect to see all work. I expect to see each problem neatly done on paper. I will look at this. I want to know that you're practicing and following along. And my advice is, as you practice it, I would group these into the groups like I have here. For example, I said, how do you solve equations with variables on both sides? Into sections. Group them with variables on both sides, the distributive property with both sides, and then we're going to do infinite solutions and no solutions. Keep them together where you can make notes and that kind of thing. Alright, so go ahead and pause the screencast and work this problem out. Alright, as I look at this, let's work on it together. Always draw that line of scrimmage. It's more important now than ever to draw that line of scrimmage to separate the two sides. Alright, as I do this, I can say 5x minus 1, nothing there that I can combine, nothing here that I can combine. Again, I'm just going to move the smaller. I want to keep it positive. So I need to get my variables together. So in this case, I have 1x. Again, if there's just a variable, it's understood that there's a 1. You can write the 1 there if you want, or you can just leave it x. I like to just leave it x. I'm going to do the inverse. That's a positive. So I have to subtract. If I subtract on this side, I have to come across that line of scrimmage and subtract on this side. 5x minus 1x, that's going to give me 4x. You gotta look at the negative minus 1. I didn't do anything to it, so I have to just bring it down. Always look at the operation sign there, which equals here x minus x, and I look and that's a positive 15. So now I have 4x minus 1 equals. Alright, as we look at this, next we'll go, you have 4x minus 1 equals 15. I got to get rid of that 1. Again, I look at that sign. That would be a plus 1 because it's the inverse of negative. Do it to that side. Again, just bring the 4x down. That's going to be nothing. Negative 1 plus 1. And then I can go equals 15 plus 1 is 16. I have to divide both sides by 4 because again I'm looking at they multiply inverse. So that means I do the opposite. Divide by 4, divide by 4. X is going to equal 4. Now, what I can do to check my answer is I can take that 4 and I can substitute it back in for the x. For example, I say 4, because I just took the 4, put it in for that x, minus 1 equals. And then I can go here, I say, I take this x, I put a 4 plus 15, I just substituted it in, equals. Well, 5 times 4 is 20, minus 1, 19. 4 plus 15, 19. So I know this solution is correct. And again, this has one solution. And when I plug it into both sides, I get an equal solution. So that's how I know that I've mathematically done this mathematically correct. Alright, I want you to take a minute, go ahead and work this one out, and then we'll talk about it. Alright, this one I have 3 plus 5q equals 9 plus 4q. Well, I want to get my q's together, get my variable together. In this case, I have the positive 4. I'm going to move it over because I want to keep it positive. So I can say inverse of positive is negative. And I'm going to put a little curve there at the end so it doesn't look like the 9. So the 3, I can bring it down, didn't do anything to it. 5 minus 4 is 1, so that's positive plus, I can say 1q, or I can just say q equals, bring the 9 down, plus 4q minus 4q, that cancels out. So now I have 3 plus q equals 9. Well, I need to get q by itself. Well, I take the 3, I have to use the inverse, subtract 3, and I don't divide here simply because it's not 3q. They're not multiplying, right? They're adding, so I do the inverse. 3 minus 3, 0. Bring that q down, is going to equal 6. 9 minus 3 is 6. Again, if I substitute this 6 back in for the q, I can do that. I can say 5 times 6 is 30, plus 3 is 33. 4 times 6 is 24, plus 9 is 33. So 6 is the right solution for this equation. Alright, what I'm going to do, I'm actually going to wait on this one because when I did it, I didn't mean to put it here, but we will definitely deal with this in just a little bit. So what I want you to do now is take a few minutes, work these 3 problems out. And then when we check them, if you have all 3 right, or at least 2 of the 3 right, I feel like that would be great. If you miss 2 of the 3, as I would definitely go back and rewatch it and work through the problems one more time. So go ahead and pause it and work through these problems. Alright, So for the first one, you should get P equals negative 9. When I work through the second problem, alright, as I look at number 2, when I look at that one and I work through it, I should get y equals 2. And then the last one, now this one's a little more tricky, had a fraction involved or decimal, either way you want to look at it. C is going to equal either negative 1 3/4, negative 7/4, or negative 1.75. Either way, that will fit in, and as you substitute any of these back in, you will see that they will make the equation equal on both sides. Again, if you got all 3 right, or 2 of the 3 right, you'll be able to go on. If you missed 2 of them, as I definitely go back and rewatch the first part of the screencast again. If you missed any of them, make sure you go back through and find what you did wrong. And if you have any questions about the process, guys, you can either tweet it to me or text it to today's meet, where you'll find at the end, you'll have the address just in case you can't remember at home. But what I want you to do now, you're going to choose one problem. It could be from any of the practice, and write a short summary of how to solve the problem. It doesn't have to be a page long, but I do want nice sentences explaining how do you do the problem step by step. And I will want to look at these tomorrow, so make sure you do it a good job and be specific. Alright, as we look at this one, again, as I'm going to go back to the document cam, this is another one. Go ahead and, well, let me show you where to go. This one will go on the inside.
Teachers, this is a new bus schedule day. If you're on bus...
Alright, now, we're going to write this problem. It's on the inside flap. And you will actually have 2, and then parentheses, 5x minus 1 equals 3, then parentheses, x plus 11. All this does is add just like one more step. There's not a huge amount of extra work to this, and we've already dealt with this, the distributive property. It's just a matter of doing it twice, really. And then, as you'll notice, we'll just have a multi-step equation and work through that to solve for x. So let's look at what we do. I want to take this, and I'm going to distribute 2 times 5x equals 10x, and then 2 times negative 1 is negative 2. Again, I got to look at that in front of the 1. It's a negative sign, so 2 times negative 1 is negative 2. That's that whole side. Now equals. Now let's do the other side. Well, I have 3 times x gives me 3x. 3 times, and this time it's a positive 11. I have a plus there, so it's a positive 11. So now we end up having 10x minus 2 equals 3x plus 33. Well, from there, I just have my multi-step equation with variables on both sides. So I want to move the one that's going to keep it positive. If I subtract 10x, then I'm going to end up with a negative, and that's no good. So let's try to keep it positive. So 3, I want to say minus 3x because I do the inverse. That's positive. I've got to go negative. So I'll say minus 3x, and then I'll go back over here and subtract 3x. And that's going to give me 10x minus 3x is 7x. Didn't do anything to this minus 2. Just bring it down. Equals 3x minus 3x. That's gone. So the only thing left, again, I look and see that's a positive. So it's 33. So I'm left with 7x minus 2 equals 33. Got to get x by itself. So I begin with everything around it. I have a negative 2. Again, I pay attention to the sign in front of it. Negative 2. In that case, I've got to do the inverse. Minus 2 plus 2. And if I add 2 on this side, I add 2 on this side. So that leaves me 7x equals 35. When I do that, I divide both sides by 7. Because again, I look at this and they're multiplying. And I just want to get rid of the 7. Don't want to get rid of the x. So 7 divided by 7. 35 divided by 7. X equals 5. And I'll give you a second to finish copying that down. And then we will practice some of these. Okay. All right, let's go back to the screencast here. And that's the one we just did. So let's look at this. What I want you to do is go ahead, practice this one, pause the video, work through it, and then we will work through it in just a minute. Alright, let's look at it. Again, first thing, it's always super important, draw that line of scrimmage to separate the two. I've got to distribute. The 4 is next to it, so I need to clear these parentheses. 4 times 2y, 8y. 4 times a positive 1 would be plus 4, which equals, again, same thing, 2 times y, 2y, and then on this side, 2 times a negative 13. So again, I have to pay attention to the negative, and that's going to give me a negative 26. Positive 2 times a negative 13 gives me a negative 26. And now I'm back down to having a multi-step equation with variables on both sides. So I want to move the variables, get them on to one side. It's going to be a lot easier to move the 2y. So in this case, I look at a positive 2. So the inverse minus 2y minus 2y. Well, that gives me 8 minus 2, 6y. Don't forget to bring down your y. That will change everything. Bring the plus 4 down. That's going to equal, well, here, 2 minus 2. That cancels. So that just leaves me with negative 26. Go back down. I want to move everything out to solve for y. I have a positive 4. So I'm going to go inverse. Subtract 4. That leaves me 6y on this side. Equals. Be very careful here. If you're not careful, you'll say negative 26 minus 4 is negative 22. But it's not. Remember on our number line, when you're subtracting from a negative, you're actually going to get negative 30. Solve for the y. Divide both sides by 6. And I'll get y equals negative 5. If I want to, I can take that same thing to test it and take my negative 5, plug it in. 2 times negative 5 is negative 10, plus 1 would be a negative 9, and that would be multiplied by 4, and that would be what, negative 36? Well, negative 5 minus 13, and that's going to give you what, negative 18 times 2, negative 36. So negative 5 fits as your solution. Again, just to check it, just plug it back in for the variable and use your order of operations. Alright, let's look at this same kind of thing. You got 7, and then 4 minus a equals 3, then a minus 4. Go ahead and pause the video and work this one out and see what we come up with. Alright, now look at this. I say 7 times 4, 28, minus, because I know positive times a negative, 7 times negative a would be negative 7a, equals, well, in this case, same thing to this side. just distribute 3a, then 3 times a negative 4, pay attention to that, 3 times negative 4 minus 12. So in this case, now this is one, it's a little bit different. We've been looking, making sure we try to stay away from being negative. Well, instead of subtracting 3a, because I have a negative 7 here, well, if I have negative 7, I can add that. I can say plus 7a and move that one. Plus 7a on this side. That clears the negative. It leaves me 28 on this side equals 3 plus 7 is 10a. Just bring down my minus 12. So now I have 28 equals 10a minus 12. Add 12 to both sides. And I'm going to get 28 plus 12 is 40 equals 10a. And then that cancels out, minus 12 plus 12. Divide both sides, again, because I'm trying to solve for a, by 10. 40 divided by 10 is 4 equals a. And I hope you came up with the same thing. Alright, here's another one. Now this one I'm going to tell you up front, be careful with this one, because this one can trick you. Alright, let's look at it. Let's see if you came up with the same thing that I will come up with. In this case, if I look at the problem, there's nothing I can combine here. Be very careful to say, oh, I can combine 2r minus r, because there's something you have to do first. You have to clear the parentheses. Order of operations comes into effect. So I say negative. Look at this is what is next to the parentheses, so I have to distribute the negative. Negative times 5 be negative 5. But then here, negative times a negative r. Negative times a negative is going to make that plus r. Now don't forget about what we had before. We didn't do anything to that 2r, so I'm just going to bring it down. Equals 13 plus 2r. Didn't do anything to that. Again, if I have a negative right next to the parentheses, I have to distribute it. And that will change your problem if you miss that. So now let's look on this side. I do have something I can combine. I look at the 2r plus one more r. 3r minus 5 equals 13 plus 2r. So I just simply combined my 2r and plus, because it's in front, there's a plus in front of the r. So now I'm back to a multi-step equation, variable on both sides. I want to keep it positive, so let's go ahead and subtract 2r from both sides. And that's going to get 3 minus 2. It's going to get my variable to that side. That's going to cancel out. Bring down my minus 5 equals 13. Now in this case, they're subtracting. I do the opposite. I add 5. And r should equal 18. Now if you came up with something different, I'm willing to bet you probably didn't distribute your negative. But look back through mathematically, look and see what you did. If you missed it, if you got that one on that, great job. Way to pay attention to your negatives. Alright, one more. Let's go ahead and pause the video and work through this one. Okay. Draw my line of scrimmage. Always do that. Now here's where you have to be careful, because you have 5g plus 4 and then the parentheses. Well, in this case, it's just like what we were dealing with multi-step equations. I'm going to say, okay, 5g, not doing anything with it. But now I am going to do something with this positive 4. 4 times a negative 5 minus 20. Positive times a negative. And then I have a positive 4 times 3g. It's a positive 3. Positive 4 times 3 plus 12g equals 1 minus g. Didn't do anything to that. So again, positive 4 times negative 5, negative 20. 4 times a positive 3g would be a 12g. So now, I look, do I have anything I can combine on this side? I do. I have 5g plus 12g. 12 plus 5 is 17g minus 20 equals, didn't do anything to this side, 1 minus g. So again, I want to get my variables to one side. Easiest thing here, just move the g right over. Opposite of what they did, I'm going to add 1g. 18g minus 20 equals 1. Those cancel out, minus g plus a g. So now if I look at this, I have 18g minus 20 equals 1. Well, here, I've got to get rid of that negative 20. Pay attention to that sign. Plus 20 and plus 20. So I have 18g equals 21. So I'm going to rewrite that here just for room, because I've got another step here. Now here I'm going to divide both sides by 18. And I'm going to get g equals 21 over 18. Now I can reduce this, divide both sides by 3. They're both divisible by 3, and that gives me 7 over 6. So I can get g equals 7/6. And if you want to turn that to a decimal, you can turn it to a decimal. If you want to turn it to a mixed fraction, you're welcome to do that as well. And I know that's a lot of steps, but the process, it never changes. All right, what I want you to do, work these two problems out, and let's see how much you can remember. They're no different than the others, and we'll check them in just a minute. All right, as you work these out, for the first one, you should have come up with b equals 7. And for number 2, when you work it out, you have a is going to equal negative 37. What I want you to do is take a minute, find somebody in your house, and share with them, walk them through the steps to solving one of these two problems. Again, don't forget number 1. Don't forget that negative. That can be tricky and throw you off easily. Alright, and the last part on the foldable is, how do you determine if an equation is an identity or no solution? Well, let's go back to our foldable real quick. And the way we work this isn't going to be any different. We're just going to see a little bit different result in our answer and our solution. So on this one, and this I want you to copy this one down. 10x plus 12 equals 2 times 5x plus 6. Well, as I do that, I'll get 10x plus 12 equals, don't forget to distribute, 2 times 5x, 10x, and then 2 times a positive 6 would be plus 12. Draw my line of scrimmage, and I'm going to notice here, I'm going to get my variables together, and this is what I was talking about earlier about getting your variables together. It's going to make it a lot easier in the end. This is what I was talking about. Right there I have 12 is going to equal 12, and that is going to be an identity or infinite solution, because 12 will always equal 12. So this is going to be identity. Alright, now what I want you to look at is this one right here. How do you determine if an equation is an identity or no solution? On your foldable, underneath the one we just talked about being an identity, I want you to write this equation. 9m minus 4 equals negative 3m plus 5 plus 12m. Because it's important, as we saw that was an identity where 12 equals 12. It can also be seen as infinite solutions, but an identity. You'll see both of those terms used. Whereas this one's going to be just a little bit different. Go ahead, take a second, work this out, and see what you come up with. Alright, so let's look at this one. When I draw my line of scrimmage, I look at each side and I say, okay, what can I combine? Are there any like terms I can combine? On this side, there's not. So I'm just going to say 9m minus 4. On this side, I have negative 3m, but then I have a plus 12m. Again, I have to look at this sign in front of it. So negative 3 plus 12, it's going to be a positive 9m. Then plus 5. Well, to go to this next step, to get my variables on both sides to one side, again, I always want to do that in the beginning when I said make a good habit of doing that, because it will make it easier later, as this is really that time. Alright, so when to get my m's, I'm going to say subtract 9m because they have a positive. I got to go inverse. Minus 9m gives me 0, gives me 0. So really that just leaves me negative 4 equals 5. This is not a solution. This is not true. And it never will be true. The negative 4 will never equal 5. So in this case, that would be a no solution. So in comparing, when you have the same solution, like for example when we have 12 equals 12, that's an identity. We have this case, we have no solution. Alright, I want to have you work through just a couple of these. There's not a lot of these, but just to get some practice at determining, is this a solution? Alright, so as I look at this problem, let's draw our line of scrimmage. And then the first thing I know I need to do, I've got to distribute 2 times the a. Then I distribute again 2 times the negative 4, paying attention to that negative. So 2 times negative 4 is negative 8, which equals 4a. Now here's where it gets tricky. Make sure you distribute your negative and not the 4a. So negative times 2a minus 2a, negative times 4. Negative and a positive minus 4. So in this case, as I look over here, there's nothing to combine on this side. I'm going to go ahead and bring it down. 2a minus 8 equals 4a minus 2a. Well, that's 2a minus 4. Then I subtract my 2a from both sides. That's the inverse. Leaves me negative 8 equals negative 4. In this case, there's no solution. Alright, I'm going to go ahead and skip a couple of these problems. And I'm going to go have you, to do this, I'm going to have you tweet or text the difference between infinite solutions and no solutions when solving equations. I want you to tweet it at Coach T.M. Smith and hashtag refuse to lose 2. Don't forget to text any questions you have, either Twitter or Today's Meet. And if you choose to use Today's Meet, use in the address bar, second block would be todaysmeet.com/secondmath8. Third block would be todaysmeet.com/thirdmath8. As I prefer that you use Twitter because it allows so much more discussion about these topics. But if you don't have a Twitter account, you are able to use the Today's Meet as a backup. And this is part of the assignment, so make sure you do this as well as with everything else. And I will see you tomorrow in class.